All right, here's another example of solving a system of equations using the substitution method. However, this time we don't already have a variable isolated. So that means we're actually going to need to do step 1 of isolating a variable. Now, we could isolate any variable. However, what we're going to end up wanting is we're going to want 1x or 1y equals an expression. So if there is a variable that already has a coefficient of 1, I'm going to want to isolate that variable. And if I look in that first equation, I have negative 4x plus y. Well, that plus y means that y has a coefficient of 1, positive 1. So I want to isolate that y. That will be the easiest y to isolate. So off to the side, that's what I'm going to do. I'll do that in blue. So you have negative 4x plus y is equal to 6. Well, to get y on its own, I need to move the 4x to the other side. So we're going to add 4x, add 4x. So we get y is equal to 4x plus 6, because I can't combine those. So now I have a variable isolated. So now I can substitute that expression in for my variable. So again, I know that y is 4x plus 6. So I'm going to plug it in for y in the other equation, making sure you're plugging it into the other equation. If we plugged it into the first equation, well, we can't plug it into itself. So we need to plug it into the other equation. So let's do that. So again, just to help me organize my work, I know my answer is going to be an ordered pair. So I'm going to take that expression that y equals, and we're going to plug it in for y. So you have negative 5x minus, and we're going to put it in the parentheses because we're actually going to have to distribute that negative to each term of y. So 4x plus 6 is equal to, oops, that's not how I wanted it. I'm used to the line, equal to 21. So now I need to simplify and solve for x. And the reason I put that in parentheses because we're actually going to need to distribute the negative to both the 4x and the 6. So you get negative 5x minus 4x minus 6 is equal to 21. Still solving this for x, negative 5x minus 4x, that would be the same as negative 5x plus negative 4x. So that'd be negative 9x minus 6 is equal to 21. Next step is to then solve for x. So we're going to add 6. So we're left with negative 9x equals 27. Solving for x one more time, we have divide by negative 9 because we have negative 9 times x, so we need to undo that with division. So negative 9 divided by negative 9 is 1, so we're left with x, and 27 divided by negative 9 is negative 3. So the x value of my solution is negative 3. I'm not done yet because I also need the y value. Well, I know that y is equal to 4x plus 6, so now I know what x is, so I'm going to plug it in for x. So y is equal to 4 times x, which is negative 3, plus 6. So y is equal to 4 times negative 3, so that'd be negative 12 plus 6. Well, negative 12 plus 6, the negatives are winning the war, so my answer is going to be a negative. And there are 6 more negatives, so it'd be negative 6. So my solution is the point negative 3, negative 6. Now I can do the really cool thing on solving systems is check my work. Kind of already checked it with the first one, so really I just need to check it with the second one. So we have negative 5 times negative 3 minus negative 6 is equal to 21. Negative 5 times negative 3, that would be 15. Subtracting a negative is the same thing as adding the positive. And 21 equals 21. So this checks.